So we've made it to week 6, the final week in this course. We've covered a ton of material, and to tell you the truth, I've kind of struggled with how to end this course. The inclination, or my natural tendency, would be to end with the topic of mastering. And mastering is what you do to the final 2-track process. So you mix your entire track down, you export it as a single uncompressed WAV file, and then you master it, which is giving it one kind of once over with digital signal processing, fine-tuning the beginning and the end before you release it as a CD or as some kind of downloadable medium. But I don't think we're quite there yet. I'd like to talk more about the fundamentals of sound and talk about something that really helped me in my growth as an artist, and that's synthesis. And once I started learning about synthesis, I started getting a language for timbre and a language for sound. And I started hearing things a little differently. Because we don't really have a natural language for how to describe how kind of a note evolves or how it starts and ends. Or how the timbre sounds different between an oboe and a violin. It's hard, we don't have words for it. And the idea is synthesis and learning how to create sounds from scratch there gives a language for sound and a way to kind of describe it and a way to kind of memorize it and remember it. So I think it's very valuable. And besides that, a synthesizer is a hugely important tool in the contemporary productions. I mean, we hear synthesizer sounds on everything. And even when you're hearing real instruments, very often it's a sampled instrument. You hear a violin, very often that's a sampled violin. And when you're working with a sampler, using the same modules, the same components that you learned when working with a synthesizer. When you're dealing with MIDI data, very often you want to manipulate that sound. You get to the point where you find a patch in a synthesizer or in a sampler that's really close to what you want, but not perfect. Well, knowing just the fundamentals of synthesis will help you make it to be that perfect sound, so it fits just right in your production. So in this week, we're going to cover the fundamentals of synthesis. And it's going to be 5 modules. And really, most of synthesis breaks down to these 5 modules and just various ways of connecting them. In fact, one of the versions or names for synthesis is modular synthesis, just because there's these simple building blocks that connect together. And these 5 modules are the oscillator, the filter, the amplifier, the LFO, and the envelope. And we'll look at each one of those in turn this week. But as a broad overview, the oscillator is what creates the sound. And very often it's a bright, buzzy, kind of aggressive sound based on a square wave, or like a sawtooth waveform, or some other geometric waveform. The next object, or module, is your filter. And its general design is to remove the unwanted frequencies. And the low-pass filter ends up being the most important of the filters, because as we saw earlier, the low-pass filter lets the lows through and cuts the highs. And because the oscillator is so bright, the filter removes that excess high end, making the oscillator sound a little more like a real-world sound. The last module we have after the filter is going to be the amplifier, which is going to control the volume of that sound over time and control how it develops over time. And the time factor is really important because synthesizers are not static things. Though the filter is similar to the EQ, the difference is a synthesizer filter is meant to move over time. Though the amplifier is similar to a gain knob or a volume fader, the synthesizer amplifier is designed to move very quickly over time. And that developing over time, that change over time in synthesizer land is called modulation. And really we have 3 kind of main modulators. The first is you as a user. You can turn knobs and manipulate the sound over time. But there are 2 really important kind of algorithmic modulators. Ways that you can kind of give instructions so that the synthesizer itself can control other parameters within the synth. And those 2 devices are going to be your LFO, which creates cyclic variations in any other parameter, or the envelope, which creates kind of a shape that runs every time a key is pressed. Very often, the LFO is controlling the pitch of the oscillator. So we get kind of a vibrato, a pitch wavering like a natural singer has. And the envelope is almost always controlling the main amplifier, which is how we can make the amplitude change over time to give it a percussive shape or a sustaining shape. Now, though I've talked about an LFO controlling pitch, we can have an LFO controlling many things. I can have an LFO controlling the filter, or one controlling the amplifier, or a variety of other parameters. The envelope too. I can have an envelope controlling pitch, or an envelope controlling the filter. In fact, I can have more and more envelopes and more LFOs. LFOs controlling LFOs. It kind of builds up. It's kind of a big formula as you start connecting these modules in various ways. We're going to focus on the fundamentals though, and we'll look at those 5 objects and a really basic way they can be connected. And I think you'll find once you understand that, synthesizers and samplers in general will make much more sense.